This math talk is just a continuation of what we were doing in the previous math talk when we were looking at the addition of two integers. So what we're going to do is look at the subtraction of integers, and we'll start with evaluate, in this case, -3 subtract -5. Now our strategy for addition was simply to remove all brackets and eliminate double signs. We're going to do the same with subtraction. So we begin by writing the -3 subtract the -5, and I like to fill in a positive sign. I don't have to do it on the paper, but I can do it in my mind, just to remind myself that if there is no sign written in front of an integer, it's understood to be positive. So in this case, I have a set of brackets. I understand in front of that set of brackets is a positive sign. So now I have, just as we saw in the last video, a positive negative, or an addition of a loss. We understand that to be simply a loss. So in fact, that addition sign and the brackets can drop away, and we just have a -3. Now the situation is a little bit different, as we learned in our video on double signs. When we subtract negatives, we get a result that may initially be a bit counterintuitive, but it probably makes sense if you think about it carefully. So in the process of subtracting a negative, we're removing a loss. Well, that's equivalent to taking away our brackets and saying removing a loss is no different than a gain. And so we convert that negative into a positive. So really what I would want to write is this: -3 followed by +5. And so if I have a loss of 3 followed by a gain of 5, I end up with a +2. Let's try another. So we have -2 subtract +7. Once again, I recognize that in front of that -2 is an invisible or an implied addition sign. So now I have what I had before, adding a negative or a plus minus, that results in simply a minus. Now, in the other situation, I have a minus plus. So in this case, I recognize that I'm subtracting a positive that amounts to a loss. So to represent that with a single sign, I write -7. And so now my expression looks like this. It's -2 followed by -7, or a loss of 2 followed by a loss of 7. And I end up with a loss of 9. What you may notice now in the first and second question is that subtraction in each case resulted in a flip of the sign of the integer that followed. Let's look at it again. So now we have +12 subtract -15. So I would write my +12 subtract -15 and recognize that removing a loss, subtracting a negative, is equivalent to a gain. And so that negative represented as a single sign would simply be a positive. And so my expression becomes +12 plus 15. And so a gain of 12 followed by a gain of 15 results in a gain of 27. And quite often I'll write my final answer just as regular 27. Once again, it's understood that there's a positive sign in front. One last one. -4 subtract 8 subtract -19. I recognize that the 8 inside the brackets is really +8. It's implied. When there's no sign marked, we understand it to be positive. So I have -4 subtract +8 subtract -19. Well, let's deal with the double signs. I'll remove the brackets, and as I look at it, I have -4 subtract +8. Removing a gain is the same as a loss, and so that positive sign disappears. As well, the negative, or the subtracting of -19, or the removing of a loss of 19 is equivalent to a gain. And so we replace the two negatives with a positive. And so my question becomes -4 followed by -8 followed by +19. Or in other words, a loss of 4 followed by a loss of 8 followed by a gain of 19. Combining all the losses into a single loss, I have -12 plus 19. That was the -4 combined with the -8 to give me -12. Now I'm down to just a loss of 12 followed by a gain of 19. I recognize that that's got to be a net gain of 7, or +7, or as I like to write it, just plain old 7. So to summarize subtracting integers, we have this. For integer subtraction, just like we did with addition, we want to remove all brackets and remove all double signs. And then recognize that whenever we're subtracting integers, the signs of the integers that were subtracted or are being subtracted are always reversed. So that second integer is always reversed. That's all there is to it. Thanks for watching.